Hello, is it audible?
Yes, sir.
Screen is visible.
Yes, sir. Yes, sir.
Rule number 14. Shrutika,
Yes, sir.
can you read this all the things? Notice.
Yes, sir.
Okay, I will just a minute. How many students have joined? Only 21 students. Okay, no problem. So actually, this is whatever the information is there. This video bites of students, which is going to help your next upcoming students. Okay, for that reason, you have to do one video bites of 1 minute. That is related to some topics. Already the topics are also there, the downside. So I will request Srutika to read this notice here now regarding this one. All of you note this one. Srutika,
Sir,
read.
रीड करू.
Ah,
विद्यार्थ्यांनी व्हिडिओ बनवताना खालील मुद्द्यांची मदत घ्यावी. 1. स्वतःची ओळख, नाव, गाव किंवा शहर. 2. वर्ग व ब्रँच. 3. स्वेरीमधील कोणकोणत्या बाबी किंवा उपक्रम तुम्हाला आवडतात. खालील एकूण 35 उपक्रमाची नावे दिलेली आहेत, त्यापैकी निवडा. स्वेरीच्या संस्कृतीचा तुम्हाला कसा फायदा झाला किंवा होतोय. शेवटी म्हणा थँक यू स्वेरी. स्वेरी इंजिनिअरिंग फॉर एक्सलन्स. सूचना. व्हिडिओ 1 मिनिटाचा असावा. व्हिडिओसाठी शांत ठिकाण निवडावे. मागे प्लेन बॅकग्राऊंड असावे. बोलण्याची भाषा मराठी असावी. इंग्लिश असेल तरी पण ठीक आहे.
so these are the topics. You can consider the topics. So already I have saved this message in the group also. So nearly 34 topics are there. We can choose any one here now. So if any one of you interested to do the video bites, which one we are going to publish in the very Facebook pages and website also. So other college students and other students, they are going to see that one here now related to that. So if you are interested, any one of you interested, then all of you have the WSR number, DD WSR, who is handling the power system on subject for you peoples. You contact him and you can provide your name and class details to him, and you can send the video and you can send to me and WSR. Both you can send through your WhatsApp also. Okay, this is one notification that is related to that. It is not compulsory for all, only for interested candidates. If you are interested, you can do this one. So interested candidates, you provide in the proctor group, you tell write your name and topic interested here now, roll number, name and topic interested. You can send in the proctor group. Okay. So next what we have to do, we'll start the actual syllabus. That is where we have stopped in the last class. Classifications of transducers. Okay. So the previous class we have discussed about what do you mean by that resistance temperature coefficient, how the resistance increases for the positive temperature coefficient, negative temperature coefficient, what it is going to happen. For some materials are there, the resistance material which will be, there is no change at all for different temperatures, resistance value will be constant, that is constant ton. And manganese materials, for the pure metals, if the temperature increases, then the resistance of the pure metal will be increases. Okay. Some semiconductors are there, for the semiconductors, silicon and germanium. If the temperature increases, then the resistance value will be decreases, that is called negative coefficient we have called. So these are all the things we have discussed in the last class. So now we'll move for the classifications of transducers. But before that one, what do you mean by transducer? Anyone of you can you tell me definition of transducer?
It converts into one form of energy into another form.
It converts one form of energy into another forms. So in the previous class we have discussed, based on the external supply, based on the output, based on that which form of energy, like that we have classified the transducer into different methods here. So this one based on the external supply, this one depends on the output here. No, this one also depends on the which energy to which energy it is converting here. No, that is electrical to mechanical, mechanical to electrical, physical to mechanical, like that. This all primary, secondary, electrical, mechanical, inverse transducer, these all are based on the which energy to which energy. This is input to the output based classification. This is power supply, based on power supply we have classified here now. Actually, this one only we are going to consider active transducers and passive transducers here. There are the first one, active transducer. Active transducer means which does not require the external power supply here. The device or the transducer which does not require any external power supply to conversion from one form of energy to another form of energy. And now those type of devices we are going to call, that is called active transducers. Such type of transducers develops their own voltage or current. These devices, they are going to develop their own voltage or current here. Now for that reason, the active transducers are also called as a self-generating transducer. We are going to call this active transducers are also called as self-generating transducers here now. The output signal is obtained from the physical input quantity here now. The output signal is obtained from physical input quantity here now. From the physical to it is output, electrical, mechanical, like that we are going to get physical quantity to other form here. So example that is called the piezoelectric crystals and photovoltaic PV cells are there, tacho generator, thermocouples, solar cells are example of active transducers. Yesterday we have discussed these all the things already. So the passive transducer means which requires the opposite to the active transducers. Active transducer does not require any supply means, but for the passive transducers, it which requires the power from the external supply source is known as passive transducers. So they are also known as external power transducers here. So the examples are thermistors are there, strain gauges are there. So these are the examples of passive transducers. Next one is analog transducers here. Analog means the output will be in analog condition only, continuous rotation only, it will be there over there. So for that reason, the analog transducer changes the input quantity into continuous functions here now. Analog, it should be continuous, there is no stop at all over there, continuously it will be flow. Analog watches, you can see that one here now. From 12 again it will continuously flow that one here now. So example, that is LVDT is that linear variable differential transformers. Strain gauges are there here now. Thermocouples, thermistors. These are all some examples of the analog transducers. So digital transducers next. These are opposite to the analog transducers. These input quantity into digital form, digital signal, they are going to convert that one here. Now the physical quantity into digital form, that is the example analog watch and digital watch also you can consider that one. That is transducers here now. So the digital signal work on high or low power here now. So optical encoders, decoders, we have heard the name. That was all was there in the first year also. So that is analog and digital transducers. Next, these are very important here now, the primary transducers and secondary transducers. Actually, we are going to call here now. So physical energy into electrical energy, we are going to call one form of energy into another form of energy, that is called transducer. But primary transducer, what they will do, they are going to convert physical energy into physical form of energy into mechanical energy. Then in the secondary transducer, we are going to convert that mechanical to electrical. So the transducer consists the mechanical as well as the electrical devices here. These are consist of mechanical and electrical devices here. The mechanical devices of the transducers change the physical input quantities into a mechanical signal here. The mechanical devices, what it will do, they are going to change the physical input quantities into mechanical signal. Then this mechanical device is known as primary transducers here. The Bourdon tube we are going to use as an example here. The secondary transducers converts the mechanical signal into an electrical signal. The previous primary, what we have, physical quantities are converted into mechanical. Here in the secondary transducer, the secondary transducers converts the mechanical signal into electrical signal. The mechanical signal into electrical signal, they are going to convert. The magnitude of the output signal depends on the input mechanical signal here. Now, how much input mechanical signal will give, based on that the value of the electrical signal, it is depends on that one. The value, magnitude means the value here now. So that is next one here. The next type is called transducer, which converts the non-electric quantity into electric quantity, is known as transducer. Why we have considered main transducer definition? Inverse transducer is important here now. Transducers, they are going to convert the physical into electrical, we are going to consider, suppose, okay. But the inverse, which converts the electrical quantity into physical, the opposite of the transducer, the definition is one form of energy to another form we can consider, means that is general transducer. But the electrical transducer, that is called, which converts physical quantity into electrical, then the inverse transducers are called, which converts the electrical quantity into physical quantity, we can consider here now. Such type of the transducers which converts the electrical quantity into a physical quantity, such type of transducers is known as the inverse transducer. So the transducer has high electrical input and low electrical output here now. They have the electrical input is high, but low electrical output they are going to get that. Next, based on the electrical and mechanical here now. So the electrical transducer and mechanical transducer we are going to discuss here now. It is a device which converts physical quantity directly into the voltage, current, are proportional to the input here now. Whatever it is, if we have applied a force, if we have applied a displacement, that one we are going to output, we are going to get in the form of voltage or current here. So the physical quantity is converted into electrical parameter here now. So electrical quantity, that is called electrical transducer. That is called electrical transducer. That is a example is thermistor, thermocouple, LVDT. These all are the electrical transducers only. RTD is the resistance temperature coefficient. So based on the temperature, the resistance we are going to measure here now. So like that, which converts the physical quantity into direct voltage or current form here now. That is, voltage is a electrical quantity or mechanical quantity? Voltage and current are electrical quantities only, no?
Yes, sir.
Yes, sir.
So these devices converts physical quantity into electrical quantity. So the mechanical device which converts physical quantity into mechanical quantities, they are going to convert here now. That is called mechanical transducers. So our aim is mainly we have to discuss the electrical transducers only here now. The chapter name is transducers. So which degree you are studying here? You are studying mechanical or electrical?
Electrical.
So electrical transducers only we are going to concentrate. Which one we are going to use for the measurement of conversion of physical quantity into electrical quantity here now. So according to your syllabus, RTD, LVDT, RVDT, these three devices they have mentioned here now. These three devices they have mentioned here now. See, this is the device which one we are going to use in the industries, that is called resistance temperature detector here. Resistance temperature detector. Based on the value of resistance, the value of the resistance, sorry, based on the value of temperature, the value of resistance is going to change in this device. So if the temperature changes, then the value of this resistance will also changing here. See here, this is one type of conductor. Another conductor is this one here now. In between two conductor, we have filled that one in the sheath here now. Magnetic sheath, or we are going to consider this one as cover or body here now. So in between this conductor, what we have added, some sensing element we have added here. We have added some sensing element here now. If the temperature increases, this sensing element, it will senses the temperature and it is going to increase or decrease here now. It is going to increase or decrease based on that one here now. So lead support, to get the support for the lead, we are using here now. The sheath is there. We are going to mount or fix into some places. In which circuit we are going to mount here now. That one for mounting threads they have given here now. We can, like a nut and bolt system they have provided here now. The threads are there, can fix that one here now. Two connecting leads we are using here now, 1 and 2 here now, to give the supply here, where we have to connect that one here now. So this is whatever the device is there, we have converted that one into bridge form here. We have converted into bridge form. We have considered, that is, in the bridge we have considered a balance, that is galvanometer we have here. So the resistance R1, R2, R3 and R4, RS. RS is nothing but the sensing element resistance here. Now based on this one only, the resistance temperature it is going to sense, and based on that the resistance value will be changes here. So R3 and RS and R4, R5, these three are in series if it is balanced condition is there. If it is balanced condition. Already we have studied in the bridge circuit, Whitson bridge, Kelvin double bridge, DSOT bridge, Maxwell bridge, Hayes bridge, Anderson bridge, Shearing bridge. So how it, when it will become balanced here now, if it is the bridge is balanced, no current will flow. If it is unbalanced, the current will flow here now. Like that we have already discussed here. So the construction we will discuss here now. A resistance temperature detector, also known as the resistance thermometer or RTD. Resistance temperature detector. The short form we have considered that RTD. We have considered that one. It is also considered a resistance thermometer. Also we are going to call here. Is an electronic device. It is an electronic device which is used to determine the temperature. We are going to determine the temperature by measuring the resistance of an electrical wire. एक resistance measure करने का एक wire का, उसके हिसाब से we are going to measure the temperature here. The construction and working of RTD, resistance temperature detector. So the resistance of the conductor changes with change in temperature here. If the resistance of the conductor changes, then the temperature will changes. Our temperature will changes, the resistance will changes. Both are same only here. In the figure, we have shown that the platinum resistance thermometer here. Now in the construction, we have shown platinum resistance, the material we have used platinum, in which platinum material is used as sensing element here. Now this element, whatever the dark area is there, this is called platinum material. For the sensing purpose, we are going to use this one as platinum element we have used here. So the thermometer is generally long spring like a shape enclosed in a metal sheath. It is just like a long spring we have enclosed in a metal sheath or metal cover. We have enclosed that one here. This is inserted in a medium whose temperature is to be measured. We have inserted that one in the circuit or in the area where which temperature we are going to measure on that circuit, on that area, on that block. We are going to insert or we are going to mount that one. So mounting threads are provided for perfect installation of the thermometer. To install this thermometer, they have provided mounting threads over there where we want, which room temperature we want to measure, which material temperature we want to measure, we have to fix that one. So based on that, the RTD equivalent diagram of the bridge we have drawn in the circuit diagram. So the bridge consists of sensing element resistance, that is called RS, and R1, R2, and R3 are the other resistance as an arm of bridge here. We have considered some R1, R2, R3, some arm resistance we are going to consider. The R4 and R5 are the resistances of the leads connected to the sending element here. Now here we are using, this is R4 and R5 we are using here. Now which one we are going to connect to the supply or somewhere where it is going to connect here now. So R4 and R5 are the resistances of the leads connected to the sensing element. Where we have to connect that sensing element, we are going to connect over there. Next one, at balanced condition, all of you know the formula already. At balanced condition, all of you know the formula. Here R1, R2, R3 is different is there. So the bridge alignment is different here now. So based on that, R2 by R3 they have considered here now. R2 by R3 equal to R1 divided by R4, RS and R5. R4, RS and R5. If it is balanced, then the ratio of R2 and R3 equal to the ratio of R1 and R4, RS, summation of R4, RS and R5. This is known value. This is some known value we are using. This is some known value. These two are the connected resistance values here now, lead resistance. But the sensing element here now, if the at balanced condition, we will set that one. If the sensing element resistance is different, suppose temperature vary, it is going to change here now. Based on change of this RS, the bridge will become unbalanced. If any one value of resistance changed, one arm resistance, then the bridge will become changed. So this RS is nothing but we are using platinum material for the sensing material here, no element here. No, it is going to sense the temperature. Based on that, it is going to change its resistance value. If this value will be changed, then the bridge will become unbalanced. The galvanometer is going to detect some value which is equivalent to the temperature here. So due to change in temperature, resistance, the sensing resistance, that is called RS, changes here now. RS will changes and bridge will become unbalanced. The bridge is going to become unbalanced and galvanometer shows the deflection here now, which can be calibrated to give a suitable temperature scale here now. To give the suitable temperature scale, we are going to calibrate here now. So the variation of the resistance of metal with variation of temperature is given as. Some metal materials are there, some semiconductors are there. Based on that, how it is going to vary, this sensing resistance we have shown in this here now, where the RT equal to R naught 1 plus, actually here we have to write, they are missed in the equation here now. So many corrections are also there in the textbook. Here alpha we have to use here now. Here also we have to use alpha here. So alpha is nothing but temperature resistance RTC. coefficient we are going to call. Beta is also coefficient based on different material. For one material we have used alpha, another material beta we have used here. Now for the small range we are going to use only up to here only. For the long range of material we are going to use this one, where RT and R0 are the resistance values at T degree Celsius, and RT is at T degree Celsius, R0 is at T0 degree Celsius. This R0 and RT are the initial values here now, and the final value is T here now, and final value at T degree Celsius, how much resistance is there. Alpha and beta are the coefficient or constants, depends on the metal or material here. Depends on the metals or material here. For small range of temperature here now, we are going to use the expression that can be RT equal to R0, 1 plus alpha T minus T0. Where you have seen this equation? RTC, whatever the resistance temperature coefficient, we have discussed the same equation. Yes?
Yes, sir.
Yeah, we discussed the same equations over there. So based on that, the alpha here now, that positive coefficient, temperature coefficient, negative temperature coefficient, we have discussed already. The same thing it is going to happen here based on the resistance here. Based on the resistance here now. See here, resistance temperature characteristics here now. For the copper material, if the temperature changes, then the resistance is also changing here. Yes. So for the copper material, the temperature is directly proportional to the change in resistance. For the nickel material, what will happen? The temperature, only small change in the temperature, square of the resistance will changes here now. Double here now. But for the platinum material, there is long change in the resistance is very small change, but temperature is very big change here now. For increasing temperature, only small change of the resistance will be occurs over there. So different characteristics based on the material also, its characteristic is different here. No, it is linearly proportional. The resistance is linearly proportional to the temperature. For the copper material, for the nickel, it is square of the resistance. For the platinum, it is so very slow or small change in the resistance, we can call that one. You know, this is the characteristics of temperature and resistance characteristics. So it completes the construction, working, and its characteristics. So the RTD material, it has some advantages here. Before that one, in RTD devices, copper, nickel, and platinums are widely used metals here now. These three metals are having different resistance variations. Whatever I told here, the copper is linearly proportional to temperature. Nickel is square of the current resistance is proportional to the temperature. It is square of the temperature, but resistance equal to R is directly proportional to the square of the temperature. Also, we can call that one here. Reverse here, no? Widely used metals here, no? These variation with respect to the temperature variation here, no? That is called resistance temperature characteristics. We are going to call here now. Yesterday I told that one, for the metal, if the temperature increases, resistance will increases. Yes, for the metals.
Resistance
For the semiconductor, if the temperature increases, resistance will be decreases. For some instruments are there, that is called Constantan and manganese. There is no change in the resistance, means temperature. If the change in the temperature, then there is no change in the resistance. We have discussed it. Same thing only here, but small variation is that here. So some advantages of resistance temperature detector. We are going to discuss some advantages are there. That is called, the measurement is very accurate here. Whatever the temperature measurement is there, that is very accurately it is going to give over here. The form of resistance here, no? So the resistive elements can be used to measure differential temperature here. We are going to use the resistive element to measure the differential temperatures also we can measure here now. Extremely accurate temperature sensing here. It is accurate temperature sensing element we are using here. So no necessity of temperature compensation. We are no need to compensate anything. The stability of the performance over a long period time here. It is stable for the long period of time. That is the big advantage of RTD. Some advantages are there, means it has some disadvantages also. So the disadvantages of RTD is the cost of this device is very high. Need for bridge circuit for power source here. It requires the external power supply. So this is passive transducer or active transducer it is. It requires the bridge circuit and power source. Yes. It is a passive transducer or active transducer?
Passive.
Passive.
Passive or active? सोच के बोलो थोड़ा.
Passive. Passive.
So passive transducer, which requires the external supply is there. So the need for the bridge circuit and power source here, no. Possibility of self-heating here, no. There is a possible way of it is itself, it is going to start the heating here, no, for the load and all the things, because it is connected to the external supply. Because of that, it is going to self-heating will develop in that material here, no. For that reason, the value will be changes over there. That is a disadvantages of RTD. That is called disadvantage of RTD here. So the next device we are going to discuss, that is called linear variable differential transformer, that is called LVDT. I think you have already studied this one in the first year. First year में study किया ना? था क्या नहीं subject ये LVDT? It was there or not?
Yes, sir.
Then tell me what you mean by this one. Sir. Just a minute. You just think about that one. What do you mean by LVDT? दो नहीं एक ही है वो आपका ही. Okay. So the LVDT is nothing but linear variable differential transformers. Okay. So all of you know the definition of transformer also. Linear variable, whatever the we are going to linear motion, the left side, right side, like that, it is by doing a metal part or in a iron core material in a magnetic field. How much the flux linkage is there? Based on that, the motion, linear motion, is converting into electrical signal here. So for that reason, linear variable differential transformer we are going to use. That is the device name it is came here. No, anyone can you tell me it is a passive element or active element? This one, passive transducer or active transducer here. No? You only told we have studied this subject, not subject, this device. LVDT is a passive transducer or active transducer? Only two options I have given.
Transducer.
Passive.
Active, passive.
Passive. Passive.
Passive transducer, very good. Because differential transformer we are using here. Now, transformer means when you will give the supply, then only from one circuit to the another circuit it is going to transfer. Yes. So for that reason, it is a passive device which requires the external supply is required for that one. LVDT is a passive inductive transducer here. Passive transducer which converts linear displacement into electrical voltage here in the form of voltage. Whatever the displacement is there, that one we are going to get in the form of voltage. In the form of voltage, we are going to get that one. So mainly it consists of two coils, that is called one primary coil and secondary coil. Actually, three coils are it consists here now. One primary coil and two secondary coils it is going to have here. See here, this one is primary coil we are using here now. Two secondary coils here now, S1, S2. The design is like this. Here the primary winding we have done means we are going to use here S1 and S2 here. That is called S1 and S2. One side we will use primary, another side we are going to use the secondary here. What do you mean by transformer? Can you tell me transformer means what? Okay, leave that one. You are not going to tell that one. Simply it is going to transform the energy from one circuit to another circuit with same frequency. Okay, that is just I am telling the not definition exact. Actually, in the definition we'll go call that one. It is a static electromagnetic device which it transforms the electrical energy from one circuit to the another circuit with constant frequency. We can tell that one, or the without changing the frequency also. That is the exact definition here. But in the LVDT, the linear variable differential transformers, it is like a transformer only. One circuit to another circuit, the energy is transforming here. Now, see here, the core material we are using like this here. Now, this is the core, whatever the white color is there, core is there here. Now, it consists of two secondary windings. This one secondary winding, another secondary winding, and it has consist of only one primary winding is consist here. In between these two primary and secondary winding, we have kept one soft iron core material we have kept over there. Soft iron core material we have kept here now. So, and with it is one arm is provided to do the displacement here now. To do the displacement, to rotate in the x-axis here now, movement in the x-axis here now, left and right. That is, we have provided one arm also here. This is the diagram of the LVDT here. याद करो थोड़ा क्या एक्सप्लेन किया था, कौन एक्सप्लेन किया था LVDT मींस फर्स्ट ईयर में. सेम पीपीटी वी हैव यूज्ड फॉर द फर्स्ट ईयर. सेम पीपीटी, यही पीपीटी यूज किए हमने. So here the construction is over here now. It has one core material and it has one primary winding and two secondary windings. It consists, and in between this primary and secondary we are using soft iron core material we have used with provided one arm for that one to do the movement in the x-axis here now, to do the displacement here in the form of x-axis here now. We have used this one. So next what we will do, the working condition here now. See here, actual diagram is this one here now. The AC source we have given here now. This is primary winding. The supply is given to this one here now. So according to the principle of the transformer, हमने input primary को दिया तो secondary will be output here now. So the electromagnetically it is going to connect here now, and we are going to get the EMF field inducers in this coil. We are going to get the output voltage. But we have used two coils in the external here. Secondary side, there are two coils are there. I will connect these two coils in series here now. So what I will do, some S1 and same terminals we are going to join here now. In between this S1 and S2, whatever the EMF induced in the S1, that is called E1 we are going to call here now. EMF induced in the S1 coil, that is called E1, and EMF induced in the coil S2, that is called E2 we are going to consider. We have done the connection like this here now. So the total net output of this E1 and E2 is called output, that is called E out we are going to call. E out equal to bigger value minus my smaller value, that is, it may be, I will consider as E1 minus E2. E1 minus E2 here now. E1 minus E2 here. So the differential transformer, why they are called as differential transformer, is the difference between this E1 and E2, how much value we will get, that one, that is called our output here now. That is called our output here. When the primary winding is excited by an AC current here now, when I will excite this by AC current, it produces the alternating magnetic field will be produced here now. This alternating magnetic field induces a voltage in both secondary coils here now. It will produces the magnetic fields. Because of that, the EMF will induces in the secondary coil S1 and S2 here now. This alternating magnetic field induces voltage in both secondary winding depending upon the position of the core in the hollow former. Based on this position of this aluminum core here now, or whatever the aluminum core we have used here now, that one, depending on that, it is going to produce here. So the output of secondary coil S1 is E1 we are used, and output of secondary coil S2 we have used, that is called E2. So differential output is E out equal to E1 minus E2 we have used. So this is the working of the differential transformer. Whatever, same like a transformer here now. See here, if you consider that one, it is not there. ये कुछ भी नहीं है इसमें. Okay, you consider that one here now. Whenever we will give the supply to the primary, the magnetic field will be producers, which will link with the both the secondary coil here. Which will link with both the secondary coil here. If the magnetic flux is linked with the secondary coil here now, the EMF, self-induced EMF will be induces in this coil or not? EMF will induces in the coil. Yes.
Yes.
So EMF induced in the secondary coil S1 is called, that is E1 we have used. EMF induced in the secondary coil S2 we have considered as, that is called E2 here. We have considered that is E2 here. So based on this, both are connected together here now. So it is positive, negative, and here this is positive, and here this one is negative here now. So for that reason, E1 minus E2 we are going to use here now. Like this we have considered, means plus E1 minus E2 here now. So the total output is E1 minus E2, that is differential output of the secondary transformer. Both the whatever the EMF induced in the S1 minus EMF induced in the S2, we are going to identify, which will give the output value. That one, this output of the S1 and S2, it is completely depends upon this core here now, this iron core here now. See here, directly it is not connecting. First the magnetic field will connect to this iron core. From this iron core it is going to connect here now. So maximum the magnetic field is connected to this iron core only. Yes or no? The iron core only it is going to connect here. No, if what are the positions we can do? We can explain, we can displace this one in the x-axis, means whenever we'll shift this one into left side here now, left side, on that condition the E1 is greater than E2. Can consider E1 is greater than E2. Yes, the core is shifted into left side here now. So maximum flux linkage will be there at this part here now, which is nearer to the S1 side here now. So S1 is greater than whatever the self-induced EMF in the S1 is greater than E2 here now. So E1 is greater than E2. You can tell that one. Yes. Yes or no?
Yes, sir.
So in between the two windings, we have kept one iron core here. No, the displacement, by doing the displacement of the iron core, if it is connected, the maximum flux linkage is connected to the S1, then EMF induced in the S1 is greater than E2, S2 here now. And suppose this coil is there, the iron core, I will shift into right side here now. It is going to connect here now. Maximum flux linkage will be connecting to the S2 here. In this condition, the EMF induced in the S2, that is called E2, is greater than E1. You can say that one now. E2 is greater than E1. Yes?
Yes, sir.
So E2 is greater than E1 here now. Like that, it is going to give the value here now. Suppose I will not give any movement. I will not give any movement here now. I at the center of this one only I am kept here now. The iron core, I am going to keep this one into at the center of the both the coils here now. So whatever the flux linkage is there, whatever the magnetic field linked with the S1 is equal to magnetic field linked with the S2 here now. So on that condition, E1 equal to E2. E1 equal to E2. You can say that one. Both are same here now. At the center we have kept here now. So the flux magnetic field connected to the S1 and S2 will be equal here. On that condition, the EMF induced in the coil S1 is equal to EMF induced in the coil S2. Yes, we can say that one.
Yes, sir.
So on that condition, if E1 equal to E2, then what is the output here? What is the output?
0.
0, because the differential output is E1 minus E2 here now. E1 minus E2, that is called 0. We are going to tell that. So this 0 we are going to get. For that reason, we are going to consider if the core is at center, that is called null position, we are going to call here. Now, actually based on this explanation, it has three positions are there. Three positions are there. That one we are going to discuss. Three cases are there. That is called null position. Second one is left of null position. Third one is right of null position. Left of null position. First one we are going to add center. There is only null position we are going to discuss. If the null position is there, left of null position, that is case 2. Right of null position, that is case 3. We are going to discuss in the next class here. And this is the output characteristics we are going to discuss. Actually, I have one meeting at 4:25. I have to go. 4:15 only it is started. So this is the working I have explained here. Now it has three cases actually. Case 1 is null position. Case 2 is left to the null position. Case 3 is right to the null position. Based on that, we are going to get the output here now. Left to the null position means it is left side to that one here now. On that condition, E1 is greater than E2 here now. So what is my output here now? E1 is greater than E2 means it is positive or negative?
Positive.
Positive here now. So positive value we are going to get here now. If the right of the null position, then the output will be, so E2 is greater than E1, then the output will be negative or positive? E1, E2 is greater than E1. On that condition, negative here now. If it is center, then E1 equal to E2, then we are going to get that is output is 0. 0 output means that is we are going to call as null position. We are going to call that one. Null position we are going to call here now. So this is the working of the LVDT here now. The next class we will discuss the terminals. Just a minute, I will mark the attendance. Don't leave the meeting. 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26. Roll number 26. absent. 27, 28, 28. 32, 33, 38, 39, 40. Okay. So we'll stop here only and we'll continue in the next class. So actually this part is very easy, transducers. Already you have discussed this, all the things. LVDT and RVDT, only two transducers are there. Later we'll go for the instrument transformers. Okay.